Okay, so today what I want to do is to move away from resources and look forward into dealing with networking, the ability to synchronize data across multiple computers, which is not complicated at all until it is, of course. So this is going to be in several stages and, of course, several sessions because there's no way I'm going to be able to figure this out right off the bat. The last time I did networking in like as a developer rather than just as a user has been at least 5 years, and that was kind of more mid-level stuff, not low level in C++. So I figure this is going to be several bits. First off, basic sockets connect, binding to a port on a machine, connecting to another machine. Oh, and not using TCP, using UDP, not streams, but using datagrams. So there's that. Creating a socket, binding to that socket on a specific port, sending data raw across that. Then comes several other things on top of that. One will be encrypting. You want to be able to encrypt that data that goes across the network. And of course, to do encryption, preferably probably accelerated. I'm aware there's like AES built into most CPUs, like accelerated calls. So probably something like that. And in order to do encryption, of course, you need to have keys, like public private keys on both machines. And of course, this would also probably require like each server client pair or peer-to-peer pair would require their own key sets so that if you break the key for one connection, you don't break, like if someone breaks the private key of a server, you don't want everything that all the clients send to the server to be, or maybe not. I'm not entirely sure if like there's actual like if there's a key meshing between the two, so it's like a combination of the of both public keys or something like that. Regardless, so there's encryption. There's the key exchange, at least initially, for being able to encrypt things both ways. There's also going to have to be a reliability layer because UDP is not reliable, nor is it in order. I'm not sure if I want to do in order. Maybe okay. As part of a datagram connection, which is very loose term, I need several things. I need to be able to have the option for unreliable, so I just fire and forget, don't care. Um, Reliable, and then probably reliable numbered or in order reliable kind of stuff, or maybe a combination thereof. Um, so yeah, that and that's enough. That and then on top of that, of course, would be like actually synchronizing data, resources, and component data across different programs across a network, and having to deal with the fact that hey, the network is not reliable. So and there's ping issues and stuff like that. Oh, okay, very simple. So this session will be for the very basic stuff, which will be figuring out how to do sockets, binding, addresses, ports, stuff, whatever. The very, very basic stuff. And to do that, I, of course, require a library for that. So I got that. I'm going to grab basic stuff. This, it's for network. Great. At the moment, I'll just have an executable, which is just going to be that. Um, okay, there's a very basic test application. I'll make sure that's actually going to build. Um, Let me actually just kind of add this to be debug. So faux. Can I do that? Build that, run it? Perfect. And then let's put this off to the side, because what's going to happen is I'm not, of course, going to figure this out on my own. I'm going to use the infamous Guide to Network Programming by Beej, I guess, Brian Hall. And a very recent copy of this, actually only a month and a half old now, to figure it out. So introduction, what is a socket? So there's two types of internet socket. So I'm just going to go over like a refresher. There's two sockets. There's the TCP. There's the UDP dgram. Yeah. So stream sockets are reliable in order, but they can lag out and issues with that. UDP is not. Datagram packets, they are not. Addresses. So there's two standards. There's IPv4 and IPv6. IPv4 is the classic one, 4 bytes addresses, 0 to 255 for each of the 4 bits, the 4 octets here. That's what we know. Then there's IPv6, which is a lot more, which is an address that looks like this, which is what? So this is like 1 each, times 1, 2, 3, 4, 5, 6, 7, 8. So 16 bytes. For 2 to 128, infinite addresses basically. And if I recall, there's the loopback address for that, IPv6 dash colon colon 1. Same as IPv4's 127.0.0.1. And if I recall, you can do a dual stack socket where you can run an IPv6 socket can send data to an IPv4 address. And probably also receive if it's on the right port, I would imagine. And this is how you would. This would be an IPv6 address that goes to an IPv4 thing. Don't care about subnets. Port numbers is a 16-bit, so that's 0 to 65,500 or so. Byte order. Okay, this is. Okay, so yes, this. Basically all computers right now run little endian, and network is big endian. So like you need to convert data. Anything that's larger than a byte basically needs to be converted from little endian to big endian if you're on a little endian, unless I don't even. Okay, at least for things like addresses and stuff, I would imagine that'd be true. However, like if you're sending from a little endian to another little endian thing, then maybe it doesn't matter too much. Well, I mean, if you're going from like one, between two little endian machines, and you're not using like an actual broadly used protocol, you can probably stick with little endian to reduce processing. But then if you have a big endian type, then you'd have to do conversions on that. And it'll probably be easier because little endian is just basically everything nowadays. But you still need to have... Oh, and here's the address... not addresses. The function types for conversion. Host network to short. So little or big endian to network short. Host to network long. So 32 and 64 bits. Oh, sorry, no. 60 and 32-bit. There's no 64-bit variant. Okay, then to the interesting thing, the struct types. So socket is basically a file descriptor, an integer. Added DR info, so this is an address of some sort. Flags. The family is IPv4 or 6 or unknown. Stream or datagram. There's probably other types, but these are the ones I care about. Protocol. Not entirely sure. Address length and address pointer, which is outside of this struct. Canon name, not entirely sure on that. Next is a linked list, next node. So if I recall correctly, the reason this is because, okay, yeah, it's actually kind of here. The size, there's two sock address types. One for IPv4, which is just sock address in, or in6 for the IPv6 variant. And then you put that in, and the type it tries to read is a mixture of like whatever the family is, and of course the address length, because they are probably two different ones. That's probably what this is going to go on about down here. So yeah, sock address. Oh no, this is just. Oh no, here it is. Sock address, family. Okay, so this is like a thing that kind of. This looks a bit weird. How can that fit in there? 14 bytes. Okay, I'm not even going to pay attention to this. These two are the ones I care about. So this is, yeah, it's a 32-bit 4 bytes for this IPv4 and 16 for IPv6. These are typically put in the same location through probably the sock address storage thing, I guess. The family, the port, the address. Not sure about that. Not sure about that. Okay. INET Python. So this converts an address. This converts an IP specifically to an address. So, but this wouldn't be a host name or domain name like, google.com. That would be something separate. That would be like, open this up. Man pages? Probably get host name or get address info. Get host name. We'll find out. And this is going the other way around. This is going from an address into like the actual numbered string version. For both of them, okay. Private disconnected networks. NAT. So you gotta do punch through sometimes. Not gonna care about that quite yet. I'm still thinking about basics for today. So system calls above. Bust. Okay, get address info. Prepare to launch. This does what? Okay, this can allow you to do a domain into an address info type. So the port number as a string. Okay. This hints returns that. Returns a bunch of ADDR infos. And you can use those, and you have to free them, because of course they were... Oh, that's interesting. That's returning like that. That's not great, but I can work with that. So what's happening here? This is an example that... It doesn't specify, so it'll get both IPv4 or 6. It does this based on the address you give it, hints and res, and it'll return a bunch of addresses, then it converts it and puts it out onto printf. So, okay, yeah, show IP addresses for that. Okay, yeah. All right. Then we have down here getting the file. So this is the creating the socket. The main is 4 or 6 again. Types the datagram protocol is, I'm not sure. And then we bind that socket to an address, which is a mixture of the interface, like whether it's like the Ethernet card or whatever. Like if you have multiple, so I probably have IP address show. This will be just on local network. So I have, a couple. I have the loopback device. So I can bind to that, or I can bind to the Ethernet card, or the wireless. And again, these are just internal addresses, or virtual bridge for my VMs. Okay. Now we choose a socket. We create the socket, then we bind it using the address stuff that we have. Okay, that's great. This is the old way to do things, apparently. So they prefer using get address info, which I guess makes sense. This allows you to reuse an address if you don't unbind it at the end. Okay. Connect is for sock stream, don't care. Listen, same thing. Accept, same thing. Send and receive, I believe this is the same thing. What I care about is this, send to and receive from. So this is the datagram versions of send and receive, where you say socket, message, length of the message, flags, I'm not entirely sure, and a socket address that says to whom, and the length of the socket address, to determine whether it's IPv4 or 6, and then receiving is kind of the same thing. Socket, the buffer, the length of the buffer, like the max length that you can receive, the flags, who sent it, 4/6, from length 4/6. Close and shut down. And then there's some other stuff for string stuff. Okay. So I think I have enough to get started on this, actually. I may not even need to touch this quite yet. I'll get some basic things going. So what I'm going to do is I'm going to start by doing the very basic, an address type, address and socket type. So let's see, I need to include. I need the stuff. Do I need a dependency? No, just declaration, the usual stuff, basically all of this. Do all that. We don't actually have this, nor do we have these things. It's not that, it's that. It's not this, it's network. I'm not using any of these right now. So I'll just, whoops. I didn't want to kill everything, just that. Code coverage, this stuff. So I need to go into here. So first off, an address. I'm not even going to bother with IPv4 at this point. My intention is to basically do everything in just IPv6. So all the addresses and all the stuff, and just always create IPv6 sockets and what have you. I mean, I'm willing to communicate over IPv4, but I want all like the infrastructure to be IPv6 based as much as possible. Because I'm also pretty sure at this point, IPv. I'll just kind of move this off to the side because it's not longer really required here. I'm pretty sure any computer this is going to be running on is going to be able to do IPv6. So, right. First off, this is 2023. Need that. I need this. Target sources. We'll try C first until we can't. Okay, I'm going to kind of get rid of that for the moment. I'm not actually using it. Or actually, just keep it for the moment. Address. I need this for that. And I need a couple of basic things. So, actually, maybe I just, okay, close all those. Kind of bring this back so that actually people can see what I'm actually doing all in here as well. So I can just, whoops, nope, that'll work. I am going to, so I need these two types. Or, I know that, what was it? System calls are bus. There's a specific length for IPv4 and IPv6 addresses. String length, this thing. So I need to define a network. This, which would be what? 16 times 2 plus 8. No, 20. 46 characters, I think. Actually, why don't I just figure this out? Include this types socket. I'll need this anyways. In here somewhere will be. No, apparently not. Give me this. No, it's not in here either. Somewhere in here will be the length of this, and I'm just going to make a copy of that because it's not going to change. I'm just going to grab all of these. Net, inet, in, I don't know. Okay, can I do this? Can I go into the... Ah, okay, here we go. It's 46. And this will be covered by the larger 46 anyway, so yeah, we'll just do that. It's 46. Simple enough. Address string length. And then I'm going to create a custom type, which is going to be hidden in the indef stuff. The extern. This. Struct. Phone network address. It's going to be type def. We do that, and it's a whole bunch of IP block. It's 16 IP blocks. So I'd just say IP block times 16, and this is going to be uint 8t. And I'm going to include that. Phone network. I'm going to need, of course, the usual include phone network. export. I need result type. I do not need a handle type yet. Do I have that actually for export? Name, yes. Faux network export. Yeah, okay, I'll leave it like that. Okay. A couple of starting functions. Faux export. First off is the ability to do basically this to convert enumerate. Okay, yeah. Enumerate addresses. So it's going to take in basically like the string. So char const star address string uint32t star p address count and faux network address star p addresses. And this will be a void, right? Would it fail? It can fail. So I need to actually faux result set. I need, okay, I'm going to need a type for this. Let's see, get the basics for this in place. So, kind of shut these down. Have all that. That's buffer, faux max result string size. I'll figure that out in a second. We do this. Okay. So that's one. What's the next one? The get host name thing, right? That's get host name. What does this do? This, that. Okay, that's kind of the same thing. This gets the name of the current system I'm sitting on right now. Okay. So that'll be up here at the top. Does this have an error code? It has an integer, so I presume so. Local host name, I guess. Char star p size t. Your uint32. Length. The length of the string you pass into it, so the maximum length. Oh, it would also have to be. No, it will return. Oh yeah, I don't know how it would return if it would be null terminated or not. I'll figure that out. Okay, let me get these two going. And okay, close that address. Close that. So I do already have that passed in. I need this. Phone network address, header, this, and then this, that. Okay, this will be oh no, that would be like a local result type. I'm not entirely sure what to do with these, and I'm sure. Hold on, there's going to be a Windows thing, isn't there? More references. No. Advanced techniques. Note for Windows programmers. these are the headers for Windows. So I need to do a thing for. I mean, I'm pretty sure like they use the exact, like almost the same things, like the same functions and types. They just put them in a different header, and they have this startup cleanup code that I have to deal with as well. Nice, nice stuff. Nice going, guys. In the 90s, was this? I saw something about like the, yeah, 1994. Okay. So let me get this going. This is failing for result H because I'm not pulling info. Result.h because I don't, it doesn't actually exist yet. I need the source result stuff for result set result. Okay, that's inlined. What was in the C side? Okay, that would have been this stuff. So let's do that now before we result C. With that, we put results C there. Gotta stop double tapping the dots. That will allow us to compile. Okay, great. We're at the start. We're at the starting line. So result address C. Yes, I was going to do if def in 32, right? So underscore. It's 40 underscore win 32. Else Unix ones and if win s2 Windows socket 2 TCP IP.h. Okay, do I have to do this lean and mean? Only if I include Windows H. I'm not going to deal with this quite yet. Because what's probably going to have to happen is I don't know how to deal with this. This is like global, right? Oh, and I need to link in an extra library for Windows. Okay, cool. Put that up. And this. So we're here. I need to do this. I'm enumerating addresses based on. What did I see? It was here, right? System calls or bus. This. SOC, no, not SOC address. Address info, hints, server info. I do this. Okay. So, hints. I guess, yeah. Hints. That doesn't really make sense. Hints. Whatever. I don't know. do that. Sock struct ADDR info hints. Why? Incomplete type. Okay, I have ARPA INET. I have NetDB. Struct address info. Okay, cool. Is this like a... Why? Can you... Okay, now that's not a problem. String.h for a memset. Okay, so this is fine here. But for C, it dies? Struct address info. Okay, cool. Um, why? Why is this? This is compile? This Why can we not? Okay, this is here. What's this? Is it? Is it behind this thing? Or is there like another if def? Or is this just not specified when I'm in C or something? And if I specify this, okay, what is this macro for? Use xopen 2k. Use GNU. When use GNU is defined, this is also defined. Why? Oh, here's something. Actually, like it's literally says like why is struct ADDR info defined only if x open 2k is. Actually, this is NetDB, right? Yeah. Why is basically nothing in here? Okay. You know what? I'm just going to use it. I'm just going to define use, where is it? Include directory, target coverage. So I'll kind of add it before here, I guess. Target, file definitions, private. This. I'm going to define this. Does that work? Yeah. Okay, cool. We're on the road. Oh no, I also actually have to do that's why. Okay, maybe I can't use that. Maybe I just actually have to use this. You know what? Just use this. Whatever. Just get it going. All right, enumerating the address. I was going to do two things. I need the hints. AI. Actually, no, I do have to do. No, I don't have to do this anymore. Equals dot AI family equals, this will zero out the rest of the structure anyways. Unspec. Sorry, not hints. AI sock type. This is always going to be sock dgram. Flags. Passive. Is this? Oh no, that was an example down here. Hints. Just no. I don't need the passive. Do this. Um. Get the. Oh my, can I type? A address info. Star p results equals null. It starts off at null. Then we run error code equals whatever I get from get ADR info from address string. No port. Don't care about that. The hints and NP results. At the end, I need to free ADR info, the results. -1, I believe, is the error code. Let me just... It's just not equal 0. Okay. Then I'll just kind of do abort, which is part of like what? Do that for the moment. Okay, so in this case, there's if p addresses is null, then we just return the number. So star p address count equals... Oh no, I need to count the number of results first, don't I? Because it's a linked list. This starts up at 0. What we got to do is, if that's null, then we just count. So while. I need a pointer. No, because I need to keep the pointer till the end, so I can do that. So I need like another. An iterator. The results. While this is not equal to null. Address count will increase that and move up the iterator. No. P iterator. Okay, no. What? 4. I can do this, right? For that. P iterator equals P iterator I next. Like that. Address count increments. Then at the end, I return. No. Then I leave this. Okay, so then this would be else. Only counting the results, otherwise. We do stuff, and then we would return info results of network success. Like that. Star p address count equals ADR count. So that's going to happen regardless here. Just one's going to be faster than the other. We otherwise have the 4. So while this and total count is less than star p address count. Sorry, address count. While that we increment, and then I could do both, right? I could do both. Yeah, I could just do both together. Amazing. Increment the address count. Fantastic. Then I need to do, okay, I need to convert these things into addresses. There's two types. Oh, there's two types. Or at least there's two types for now, actually. There may be others. So I need to do like a switch case. Key iterator AI family, I believe. Actually, I can just look to the right and see, right? AI family. Yeah, the AI family is. And otherwise, we have a case AF 6. Default would be some kind of like a board case for now. I'm modifying this as I'm going along. I'm not. Yeah, that's not great. Ah, well. So what's going on here? I need to be able to convert. Okay. I need to figure out some conversion functions for my address type. So static flow network address. B6 will always be the easiest, so I'm just passing in a sock ADR in 6. There's the address. It's zeroed. All 16 bytes are used. Actually, yeah, they're all each individual 8 bytes, so I don't have to do like network big little endian stuff. So I should just be able to mem copy it straight in. The address that size of 16 bytes. The address of that. Then, okay, IPv4 is a little bit more involved. Kind of say that instead. P in address. Nope. Okay. I do need to. Do I need the mem set? I don't need to mem set this because I'm just. No, I do. I need to mem set. Are 0. The first 10 bytes are 0 because The last 4 bytes are the last 4 bytes are the IPv4 address, and then where is it? I had it. Here it is. So yeah, the last 4 bytes of this, then 2 bytes previous to that are just plain old like old ones. So 10 empty, 11, 12, 13, 14, 15. No. 9, 10, 11, 12, 13, 14, 15. Okay. So mems, so I don't even need to do this for it. I don't even need to do that here either, because it's literally the same. It's just, it doesn't matter. Out address dot m block IP block 0. So I'll just kind of do that actually, just to be more careful. Set 0 times 9. And 11 0x ff. So 10 0x f times 2 bytes. So let's just kind of like make that like that. And then finally, last 4 bytes of these. So mem copy to and out address dot IP block 12 4 bytes from, sorry, that times 4 bytes and the in address of it's in address. Yeah. So if it's this case, then we want to do star p addresses equals, I'll just move the pointer forward as I go. Make it easy. Set address IPv4, which is of the iterator address, right? And then I need to probably set it to a specific type. Let me just go down and see. Because it's not actually that type. It's listed as sock address. So I need to actually say, hey, this is actually a struct. It's actually that type. And then do something similar for this sock address in. Wait a second. Okay. Okay. I this like from the big type ADDR info, you go into AI ADDR to get SYN at ADDR. So it'd be like ADDR in ADDR in ADDR. Okay, maybe. No, yeah. Okay. So we do that. We increment plus plus p addresses. That's moved to the next one. Address count, p addresses, great. Okay, let's do this other one. Shouldn't be too bad. What was the kid host name? Here it is. The result is null terminative length is large enough for the full name of the terminator. But otherwise it's not? Excuse me? So I presume it's not. Oh, here we go. The parameter should point to a buffer that will hold host name and length of the size of the buffer. Won't overwrite the end of the buffer. It might return an error, or it might just stop writing. It will null terminate the string if there's room for it in the buffer. -1 on error, an error no will be set accordingly. Okay, that's not very useful. Get that out later. Return to faux results. Network success. Now, I have those. Let me move this into a test directory. Test. Put that in there. Great. Let's get all this stuff into play here. Even though it's not really using catch yet. Okay. This will be test. Well, CPP. In here, I want to include that, which it's not doing yet because I don't have this enabled. And then what I want to do is I want to faux network address. Faux network address. Addresses times 10. What do I even bother? I should have just done that. Right address. The address string will be Google. We'll probably have both. We'll work with that. Address count equals m count. That okay, great. See if it even compiles. No, it doesn't. Why not? Another target with the same name already exists. Really? Yes, you're right. Really? And where is this? Get host name is not even here. Is that a uni standard? Yeah, it was. Okay, what was it? This was the problem, right? This thing here. This is C, so I don't have to do anything fancy that way. Network export, enumerate address for result set. Const chart, that. Okay. No, this looks right. Just not compile it? No, I compiled it. Standard int, yeah. Hmm. Oh, pointer, that's why. Test. It's just that. This is already in array, right? Yeah. So I can do this, and then I can find out. Um, I need to convert it into a name, or hmm. Yeah, I'll have to convert it into a name. That is somewhere in here, right? No, I I had this. I had this a moment ago in my brain. Something to do with this. Address string length. Let's move this down into here. I can do this. Host name. Okay, we'll put it here. Faux results? No. Void. Because it's just converting bytes into numbers. Numbers into like their hexadecimal representation up to string length. And it's a preset. Okay, network. So faux network. There's the address, and then we have a char. Address string, which will be a preset length. Always. At least this. You know, that's what matters. Has to be at least this. Put that in. Address. Enumerate stuff here. We do this. We. Okay, now I don't know. Socket. Get address info. Here, right? There was something in here for doing that. inet ntop. Wait, I can do. I need to know the family. How do I know the family? Okay, I need some extra things. Enumerate addresses. Okay. Boolean is IPv4. And then I need another one that says, is it the loopback device? Sorry, loopback. Okay. And I need standard bool for this. For booleans, which I can actually just get rid of these soon because C23, I believe, makes bool an actual proper type along with null pointer, which will be fantastic to have. I think. Okay, let's put these up here, up at the top, so... right. How do I determine IPv4? Actually, well, it's right up here, right? First 9 bytes are 0, 10, 11 are that, and then this doesn't matter what this is. As long as these two hold true, it's IPv4. So I guess I just do like a for loop. Could do like a mem compare against. I can either do a mem compare 32, but it'd be like 16 bytes, right? No, 12, 13 bytes, 12 bytes. Ah, you know what? Yeah, yeah. Zero X FF. Okay. This will probably be like unrolled very easily. I is less than 10. If address.ip block. Should this be a pointer? This is 128 bytes, right? Bits. 128 bits, so 2 bytes. No, that could be easily done on a stack. Right? Yeah, yeah, no, that's easily doable on the stack. Okay. Not equals 0x 0, false. Then ten not equal. I'm sure the compiler will come up with some fancy thing for this. But that's that. Is loopback. Or is localhost? Is loopback localhost? I mean, the same thing, right? Probably. Okay, if network address is IPv4. Ooh, yeah. Yeah, I'll just do that. If it's IPv4, 4.1.7.0.0.1, address.ipv block 12 equals 127, and block 13 is 0, and block 14 is 0, and block 15 is 1. These are individual bytes. That's easy. Otherwise, I need to go through. I need to make sure all but the last byte. All other bytes are 0. Last byte is 1. That's it. Okay. $14. Otherwise, return if address IP block 15 equals 1. Okay, so where was I? I was doing a string thing, right? Yes. Okay, to string. I say the integer of the IT family is AF INET 6 by default. And I need void const star the address equals the address. Because what's going to happen key address, because what's going to happen here is if it's Oh, network is IPv4. Fine. I don't know which is better. I just don't. If IPv4, then I need to say IP family equals AF INET. Just regular INET. And the address, the point that we're looking for, starts at an address IP block starting at 12. Just shifts everything all the way over there, and then pass that into the function that inet ptop, inet ntop that's over down here. Inet top family IP family. The address, the buffer, and it's going to be this. Okay. Check, that's not gonna be too bad. 2-4 result. Really? Undefined reference. So this, why? Why would this be? First off, it's not that. Secondly, what? Yeah. Oh, it's unsigned right now. I don't care. Result and address are both here. That's right. Oh, it's because it's... Yeah, it's C. Okay. Have I just not used this in C only code before? Or maybe it's just like an old holdout from somewhere. Whatever. Back to test. I have these addresses. Now I want to go through 4 0 is less than ADR count plus I. And I want to print where I say that. I want to do like network address to string, which passes in addresses I with ADR string. Memset this. For that, no, that size. IL stream. Okay, do that. Let's run that. Come on, nothing. Nada. Because this is probably the old, yeah. The old location. Hey, I got 2 addresses for Google. I think it was Google. Google.com. I got this. This is the IPv4. This is the IPv6. Yay. So that stuff. Let me actually check that that's actually a Google address. Yes, they are. Okay. Let me check this one as well. Copy that. IPv6 test. And yeah, it's an it's a Google address. So, it's the same thing again. They changed. Oh, it's the same one for now. Okay, so that works. That works. Both, and obviously the set address two types work. Next would be to do the socket and stuff. Sockets. Okay. So let me actually kind of refresh my brain on doing this. So, okay. We have this socket, family, socket type protocol. Then we bind it with socket we have, the address, NTDR length. The address will be either the interface plus the port or just the port and this stuff, yeah. Okay. Okay, let me try that. Socket. And of course, okay, let's close that. Let's close that. Close that for now. We'll add that. I need the handle for the phone network socket, which will just be the socket itself, I think, at this point. I think that would make the most sense. I mean, this will be like a pointer thing, right? Which I could just like convert on the fly straight to the... Yeah. No, I should be able to do that. Okay. Oh, and I need the export. Create network socket. And the socket will be a combination of both the socket and the address you bind to it, right? So that means I would need the port. I need the local address and the port. The local address could be zeroed or the loopback or whatever. If it's zero, then it'll pick any. So it's either zero, the loopback, or some other specific interface you want to bind to, I think. So both. It's those things. Do I need anything else? Like, I don't want... Do I want to bother, like, storing the address of the port inside the socket? I don't really think so. Because you would already know what it is based on the context of who created it. And you can hold the data on externally if you really want to, and in whatever form you want, rather than having it with this. It's most... Practically all the time, all you're going to need to know is, like, who... What socket do I need to send and receive? And that's it. I just need the socket. File descriptor. That's it. That's normally what I need. So is there anything else? Plus, you should be able to... Actually, hold on. You should be able to just get the address from the socket, right? Get socket option. Get hostname. Get... Maybe. Get peer name. Send to... maybe not. Whatever. Create the socket. make this C as well. I may actually be able to get it along with actually creating a C-only library for once. Nice and simple. Just closing a socket, right? Close socket. Which is probably from... Oh, these and this, please. Got that, close socket. Oh, I need to convert, right? Maybe. Or, maybe I could just do a type def. Maybe if I just do a type def, that'll be fine, right? I just say... Just that. That'll make things easier. I can make a static assert. Which I believe still requires this. Make sure that size of work socket is greater than or equal to size of int. Do that. Okay. I have this. And then I already closed it, so that's fine. Okay. If port is 0, then I would return invalid port. Otherwise, which I don't have yet, I would socket AF. Is it IF? Yeah, AF. INET 6. Like I said earlier, I'm always going to do that. Stock dgram. There's other types. I'm only going to bother with that. There's no protocol. I'm doing this hard mode, I guess. I need to make sure. Socket failure. Like a little description. I guess I'll just kind of say that. Maybe I can get the error number out and put that through as well. Not entirely sure. Yeah, I'm not sure. Maybe something like that in the future. But for now, I'll leave it like this. Okay, I need hint stuff? No, do I need hint stuff? No. I would for this, right? Or would I? Like, all I really need is... No, I don't need this. Struct in 6. I know what this is. In address, or like equals .sin6 family equals inet6 dot port equals h2 network short of the port. You do that, and then I would mem copy the content of the address in, because it is, again, single bytes, so it should be good. Should be good. Sorry, no. Bind address. That makes way more sense. Dot. That, which should be... Oh, yeah. Maybe I want to make sure... I want to make sure this is the size of... Oh, I can... Oh, yes! Ooh. Assert.h. Do a couple other static assertions to make sure some types are correct. So first off, I want to make sure size of network address equals size of in6 address. And then I need to make sure that the size of this, not size of this, that must equal the same size as the 6 and str len. What was it? I lost it. No, not bind. Socket. Here we are, right? No. Oh, no, IP string. IP string. It'll be in here somewhere. IP string. Here we go. inet. There we go. That. And none of those are going to fire, right? Uh-oh. Oh, that'll... Yeah, okay. I need to create those. Otherwise, I need to enter code equals... Oh, and mem copy means... Need that. Bind to the new socket. The address I'm providing, so... Stock. I need the base type stock address. The length of it, so the size of that. it's not equal to 0, then I would bind failure. Otherwise, oh no, if that's the case, then I would need to destroy the socket for one, right? I need to I mean, that doesn't really do much, but yeah. Otherwise, star p socket equals new socket, then return. Oh, network success. Include. That gets that. I need these 3. No. Oh, yes, here. Nine 998. 997. Okay. Create socket, destroy network socket, and then I'd have to. Okay. Just compile. Yes. Time to actually see, hey, does this actually work? So this already works. Okay, I need 2 sockets, so okay. So I got these things. So results. I need an address, which I'll just say it's empty. It's an empty address. It'll bind to something. No. Um. No. Yeah. It'll just bind to whatever. And we'll go to the first 1,024 ports are usually reserved. So I'll just say like what are the garbage ones? Like 8080. No, that's HTTP. 4200. That's used for Angular. I know that. Whatever. Who cares? Send socket. I'm not using it on this machine. That's what matters. Go create network socket. Blah 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 blah. That's redefinition result. Oh. 4201. We'll do that. Wait, can I create an address from an IP thing? Like this enumerates an address from domain, either an IP or a domain string. May as well just use that, right? Can I do IP, straight IP conversion? I could. I really could, couldn't I? No, because like if it's no. I'll just stick with the 1. Minimize the surface of whatever. Okay, in that case, I'll just kind of use this as I already have this. Do this. This will be two addresses. They're both at PIPP6, and I'll use that same address to send and receive. So, send and receive. Is it not down here? Send to and receive from. Here we go. So I need the action. Okay, let me get this then. I need this. That 6 port. I'm going to 4201 H2NS. I need these. So I can do that. Send address. No, hold on. No, I need the inet. If inet 6, blah, blah, 1. So I can. Oh, I can totally do that. That would be pretty easy to do. If I can determine the address type. Or if it fails on one, I can do the other one. That's true. Well, I'll figure that out later, won't I? Address. Okay, then I have int then code will equal send socket. For now is at least the same. I need a buffer. I need something to actually send. Do that classical message. So send data size of send data flags. I don't really think I have any. The to address, so we'll do that. This is not going to work because sock edit. Okay, I need, yeah. I need that type. We'll put it up to 128. We'll mem set it. And int receive code. Is it receive code? No, it's also like the number of bytes, isn't it? I'll just say code now. Receive from socket. See data. Size of that. There's no flags. The receive. Okay, I need this. No, because I don't know what type it's coming in as. So I would need. There was another type, a socket address type, right? Blank. Structs. DDR info, no. Sock address. Was it this one or is it? It's another one. This guy. Designed to be large enough to hold both structures. You don't know what's coming in. So you pass this. And then cast the type you need. Okay. So that's it's blank. Oh, what's the last? What's the type of this? Sock length. Sock length. Why is it? Whatever. And then it's like so and receive address. And what's the last thing? I don't know. Okay, it's a pointer because it's going to return the size that was returned. Right? The size of the receiving address thing. This is a struct. That. Right? Okay, then we do that, and then we kind of see out or segfault. We'll see in a second. Receive data. Okay, run. How far do we go? We got it. Neat. Wait, hold on. That wasn't right. That should have been an IPv6. Why is it not? Interesting. Oh, it's only returning the last 4 bytes. Right? Oh, no, no. You idiot. I was only checking... There, okay, hello world. And then... If I do, like, Google again... Right? Oh, no, that was because it was just a whole bunch of random stuff. That's why it was giving me the FFFF earlier, wasn't it? Okay. I get it now. Hmm. Okay, that makes more sense. But I am sending data. That's what matters, right? Data 1, do that, return. I send data. I received it, because it was definitely not in here, right? So if I go into here, I have 5. This is 0. Send code of 14 bytes. What's 14, right? 13, 13 plus null is 14. Wonderful. Receive 14 bytes, and the received data now has the data. Okay. I guess that's kind of like all I really wanted to do for the first session was to basically do this. I have Addresses down pat. Well, addresses down pretty well. I have a good understanding of what they are. I've broken them down in a nice little IP block thing that I understand and can work with. I got a very nice minimal thing. I can maybe do a string to address, maybe, with inet piton. And I can create and destroy a socket using just those two. And then I'm going to have to add two more functions for sending and receiving data, which I'm not quite going to do yet because I want to probably... oh, I probably need some... Okay, I probably need some other things. I need to, like, create sockets to be non-binding. So, like if I make an error or something like that, like if I was to do, say, this is, I don't know, 1, I don't care. 2, this is obviously never going to happen. What's probably going to happen is it'll try to send it and fail, or it'll send it to wherever, and then it'll be stuck for waiting. Oh no, because oops. I send it to this instead. This garbage address. It didn't send it, and then because it's a blocking socket, it'll just sit here forever until it receives something. Right, so I need to do that probably as a flag given to create. Okay, so I need a couple little things. But before I go any further, I'm pretty happy with this for whatever time I've spent on this. What I'll do now is I'll finish today. I'll create a bunch of tests that test like the basic socket and address stuff and the result codes. And then next time I return, I'll either do more on like sending and receiving or work on encryption, key exchange and encryption. Sounds like a pretty interesting and heavy topic. Maybe I'll have some refinements done by then, but like, basically I'm just putting this into like a little wrapper function. So yeah, that's that. That's the very basics of datagram socket sending stuff. So until next time, cheers.